Hello, check. Hello, everyone. What's going on? Welcome to Catalysis by Vedantu. My name is Pahul. I believe we are finally live, yes. If I'm audible and visible, please write yo in the chat box. You know the drill. So, बहुत बढ़िया, बहुत स्वागत है आप सब लोगों का. Taking a live session for an entire class after a very long time. I've been doing conversation sessions with you. So, that's cool. But today what we are going to do is something that's extremely important for the rest of your chemistry life. Okay. Today we'll study about the concentrations of solutions, and this information that we learn today is going to be useful for the rest of chemistry, be it any chapter. Especially the chapters that you will encounter in 12th class will use this knowledge directly a lot of times. Fine. So now the interesting thing is that last year also, not last year, 2 years back, I have taught this particular chapter to my students. And while teaching this particular class, I made a very interesting introduction video for the same. Okay. So what I want to do now is to show you that video again. Just have a look and I'm sure you will enjoy it a lot. Hey bro, I made nimbu pani bro, it was delicious bro.
Oh damn.
Yeah, damn.
Teach me how to make it, bro. Wait, let me put my earphones on.
Okay, do one thing. Take a container, bro. Now, put 1 spoon of salt, bro.
1 spoon of salt.
Put 1 spoon of sugar, bro.
1 spoon of sugar.
Squeeze in a lemon, bro.
Squeeze a lemon.
Now, put 1 bottle of soda, bro.
Oh, 1 bottle of soda. Okay.
Oh yeah.
Bro, this doesn't even look like nimbu pani, bro.
Where? You are dumb, bro. Bye. I'm sure you understood what was the problem in this case, yeah? The measurements on both of the sides were not the same. So the same problem is something that we face in chemistry, because in chemistry almost everything that we deal with is in a mixture or a solution, yeah? And if we don't know what's the proper concentration of the solution, if we do not know what's the proper composition of the solution, this might end up happening. Since no one of us wants that explosion to happen in the laboratory, as chemists what we do is we define certain standards. How do we write the recipes of these solutions essentially is the topic for today's class. So today's class is very important because it finds a lot of applications in the practical world, of course, and also in all the other chapters of physical chemistry we'll be using these ideas. So pay a lot of attention for today's class. Let's try to understand how to write the recipes of these concentrations. Let's get back to the board. Yo people, got the idea of why we need to understand the different ways of writing concentration of solutions? Yes, I'm sure you understand the point, right? So this is why today we are going to learn all the different ways in which we can write the strength of a solution. Okay. Now, before I write the strength of a solution, I want to ask you a question, that when I say solution, what comes to your mind? How do we define solution? Before we get into any of these, I want to ask you, how do you define solution? होता क्या है भैया, ये solution क्या होता है? Please answer me in the chat box as soon as you can. Okay. What is a solution? And a lot of people, I am sure, are thinking right now that a solution is solute plus solvent. Mayur has said that, right? So whenever we think about the word solution, always, for some reason, a binary solution comes to our mind. Yeah, Ayush is also saying the same. Now the thing about a solution is that the solution can have infinite components. Yes? If you think about the definition of a solution, what is a solution? It's basically a homogeneous mixture, isn't it? A homogeneous mixture could have multiple components to it. You could have a solution which contains water and salt and sugar. Yeah? So there are multiple solvents over, multiple solutes over there, right? So first thing is that solutions can be of multiple components. Solutions can also be of multiple phases, right? You can have a liquid solution. Air, the air that we breathe in, that is what? A gaseous solution, yeah? The alloys, this is an alloy, steel, yeah? The alloys that we have are all solid solutions, isn't it? So always keep in your mind that solutions are a very broad definition. Fine. Now, what we will talk about for our analysis is a binary solution. Fine. We will talk about a binary solution for our discussion. And a binary solution has only two components. One of the components, all right, can be called the solvent, and the other component can be called the solute. And I am sure you have some idea of what a solvent is or what a solute is. Yeah? Solvent is the medium and solute is what is dissolved inside the medium, for the lack of better words. Now my question to you is, the next question that you have to answer in the chat box quickly. Which one do we choose as the solvent? If there are two components inside a mixture, let us assume one is more, one is less. Which one of those will be chosen as the solvent? What do you think? How do we decide what is solvent and what is solute? In the meanwhile, by the time you answer the question, let me reduce the temperature on the AC. So Mayur is saying that whatever is in a higher amount has to be chosen as solvent. Mayur is saying that whatever is higher in amount is to be chosen as solvent. And I am sure a lot of you think that that is the definition of a solvent. Let me tell you, that's not necessary. Okay? It's not necessary, I repeat, it's not necessary that the thing present in higher amount is the solvent. Not necessary at all. Okay? The solvent is always chosen out of convenience. Okay? Let me give you this idea. Chosen out of convenience. This is very important. The IUPAC, everyone knows IUPAC, right? IUPAC defines that solvent can be chosen for convenience of calculations and understanding. All right? Most of the times, obviously the substance that is present more will be the solvent for easier calculation, right? But it's not necessary for you to choose the solvent which is present in higher amount. You can choose it based on convenience. So a lot of times what happens is that if you dissolve, let's say, alcohol and water, just a specific example that I'm taking. So even if you dissolve 60%, even if the solution has 60% alcohol and 40% water, still you would consider water as the solvent because it is easier to consider water as a solvent because we know the calculations that way. Fine. So most of the times higher amount is the solvent, but there is no definition like that. You choose the solvent out of convenience, and the convenience is defined by what are your definitions, what are your calculations, etc. etc. Okay? So please keep that in your mind. Perfect. Now, my dear friends, for binary solutions, we have multiple ways in which we can define their strengths. As you saw in the intro video, that if we do not define strengths, then we might cause explosions. If you are interested in becoming Dexter, have you seen Dexter's Laboratory? I don't know, that used to be a very popular cartoon back in my day. So if you want to be Dexter from Dexter's Laboratory, then you might want to cause some explosions here and there, but I'd rather you not. So now the first one is mole fraction. This is just a fraction, okay? Do you understand the difference between fraction and percent? Fraction is just A by B. Percent is A by B into 100, right? So there is a fraction, there are some percentages, there is something very simple like grams per liter, and you have percent. Percent is what? Per 100, right? Percent means per 100. Similarly, you have per million, per billion. Same thing, just the numbers are different. Then we have two very interesting ones, that is molality and molarity. These are extremely important for the rest of chemistry. ठीक है? Chalo. So now a question that is coming in the chat box is, why do we have so many different things to determine the concentration? Why can't we have a standard unit for all concentration? So Sai Jashwant is asking this question. Very nice question, my friend. And remind me of this question once again when we are done by parts per million. Okay, after parts per million, you will get the idea why we need so many different types of expressions of concentration. Okay, Ayush, yes, in syrups concentration term is written. चलो जी, तो अगले पेज पे चलते हैं. I have straight away thrown you towards the deep end, as I usually like to do. So there's a question over here, we will solve it. What we have to do with this question is we have to calculate the mole fraction of the solute. Fine. Simple hai? We need to calculate the mole fraction. How do we define mole fraction? See, mole fraction is basically equal to, it's very obvious, just read the English, mole fraction. What you have to do over here is simply moles of a solute, let's say solute A, you want to define the mole fraction for A, moles of that solute divided by total moles of the solution. Fine, moles of one solute divided by the total moles of the solution gives you a fraction, right? This is the fraction of A inside the entire mixture. English, obvious. Now, let's say we have a binary mixture. So in a binary mixture, let's say we have two components, A and B. No need to define solute solvent right now. So my dear friends, how can we write mole fraction of A? Always remember that mole fraction is represented by this Greek letter called chi. Okay, this Greek letter, it looks like a fancy X. Okay, and how you pronounce it? Chi. How do you write it in English? CHI, chi. Now you must be wondering, sir, why do we use this symbol for mole fraction? Because I'm sure you don't want to write this again and again in your notebooks. Anyway, so chi of A is equal to number of moles of A, the small n subscript A represents the number of moles of A, divided by number of moles of A plus number of moles of B. This is what? Total number of moles. Cool. Similarly, chi of B will be written as number of moles of B divided by the total number of moles. Fine. Acha ji. Shayan is asking, is it enough for IIT? Definitely, bro. It is. Now, do you notice something over here? Do you notice that if I add these two fractions, it is equal to 1? Mole fraction of A plus mole fraction of B is equal to 1. If you add all the fractions together, obviously it's going to add up to the number 1, right? It's like probability. If you add up all probabilities, 1. If you add up all fractions, obviously it's going to add up to 1. Now if we have a solution with n number of components, okay? Assume that you have n number of components. So for any component I, I can define the mole fraction as the number of moles of I divided by total number of moles, wherein N total is basically equal to the summation of N. This goes from basically you start at 1 to N. Basically, you have to do the summation from 1 to N. Get the representation, a little bit of mathematics. Understood? N total is basically N1 plus N2 plus N3 plus N4 till N. Are you saying, sir, ये पहले पढ़ा हुआ है 9th में? That's good. Some people have studied this, some people have not studied this. If you studied this earlier, it's a revision for you. If you haven't studied this earlier, perfect. Fine. So ये हो गया. Now again over here, if I do the summation, okay, of all the mole fractions from 1 to N, then this will be equal to 1. Pretty obvious, I hope. If at any point of time you think that you need some time to note things down, you can pause the video and note it down. Okay. If you have any doubts, you can keep asking me in the chat box. We have less number of people, so it's an advantage for you that you can ask as many questions as you want. Fine. Chalo. Now, let's do this question. And once we do the question, we'll feel like, yes, we've understood it properly. 46 grams of ethanol is mixed with 36 grams of water. Calculate the mole fraction of solute. And they've already given you the molecular weights. So you don't have to do any unnecessary addition and subtraction. Yeah. So, whatever. Let's just calculate the moles of ethanol, C2H5OH. This will be equal to, moles of ethanol will be equal to given weight, that is 46 grams, divided by, molecular weight is also 46 grams. So this is equal to 1. So there is 1 mole of alcohol. How many number of moles of water do we have? Given weight, that is 36, divided by 18. If you know this complicated mathematics, you would know that the answer from this comes out to be cool. Very complicated mathematics. Now, from here, for convenience, and most of the times water is the solvent, okay? So let's calculate the mole fraction of the solute. Solute is ethanol. So mole fraction for C2H5OH, which is ethanol, is equal to, this is the chemical formula for ethanol, all right? So what will this be equal to? This will be equal to moles of ethanol divided by total number of moles. So this is equal to 1 upon 2 plus 1. Yes. क्या ही कर रहा हूँ? 1/3. Yeah. So 1/3 of the mixture in terms of number of moles is alcohol, and 2/3 of the mixture in terms of moles is water. क्या ही है? Sarwan Ram, yes, we will do atomic structure after this chapter, don't worry. Alrighty? Badhiya, simple hai, there's no rocket science over here. Now, obviously, if you calculate from here, the mole fraction of water is equal to 2 by 3. Obvious, 2 by 3, 1 by 3 add up to 1. No rocket science. Today's class is one of the most simple classes that you will attend. But the thing is that this simple class has so much application in rest of chemistry, and also the next class that we will do, we will solve a lot of questions based on all the things that we learned today. So today is more of a theory class, the next class will be entirely comprised of questions. Fine. Chalo ji. Ab aate hain at the next way to define solutions, and that is mass percent. Mass percent is also written as percentage W by W, okay? Percentage weight by weight. So someone, if they have to define a solution in terms of weight percent, they can call it mass percent, they can call it percentage by weight, they can call it weight percent, they can call it percentage weight by weight. There are multiple ways in which you can refer to this particular style of writing the concentration. Now, the most simple definition that you should keep in your mind is, it is defined as the mass of solute present in 100 grams of solution. Mass of solute present in 100 grams of solution. Okay? The word solution is very important over here. The word solution is extremely important over here. So now let me give you an example. Say I dissolve, क्या dissolve करें बताओ? Let's take CO2, okay, for the fun of it. I dissolve CO2, let's say I dissolve 88 grams of this. Let's say I dissolve 88 grams of CO2 in 100 grams of water. चलो छोड़ो 88 grams क्यों करना है? Let's make it simple. Let's say I dissolve 5 grams of CO2 in 100 grams of water. Very simple. Can you tell me what is the percentage weight by weight of this particular mixture? What is the percentage weight by weight for CO2 over here? Can you tell me? Ayush, at pro classes, I am not taking any sessions right now. So it depends, man. If you want to just learn with me, I'm here. If you want to take the benefits of the pro subscription as such, then of course you would take the pro subscription. Ritik Pulkit sir is better now. We have lots of things developing over here, lots of new planning coming up. You know, because JEE Advanced is getting over, right? So because JEE Advanced is getting over, new batches are starting, etc., etc. So there's a lot of planning that he's involved in, and that's also why he wasn't able to take classes regularly, but I think he's recording his classes today or tomorrow. Only Harshini is giving an answer. Everyone else, don't you want to try? So, I'll tell you how to do this. See, my dear friends, over here, the problem is that the definition that I've given you is different from the question that I've given you. Do you see that 100 grams of water? This is only the solvent. This is not the solution, right? This is just 100 grams of solvent, not 100 grams of solution. If I have to rewrite this statement, I can write that we have 5 grams of CO2 in 105 grams of solution, yes? Do you realize this? Solute plus solvent equals to solution. Always keep in your mind that this says 100 grams of solution over here. So now we have to convert this guy into this statement. We have to convert this statement into this statement. So how will we do that? We'll use our basic mathematics unitary method. Yeah. So I can say that we have 5 by 105. God bless my handwriting. Of CO2 in 1 gram of solution. Isn't it? Divide the entire statement with 105. Left side and right side divide by 105. Yeah. So we have 5 by 105 grams of CO2 in 1 gram of solution. So multiply both sides with 100. And इसको पूरा 100 से multiply करो. यहाँ पे भी 100 ग्राम हो जाएगा. Now we have this. This, my dear friends, is basically the percentage weight by weight of CO2. So in this particular example, percentage weight by weight of CO2 is equal to this number, which will come out to be a little less than 5. Okay? You can do the calculation. 500 by 105. How much does that come out to be? Can anyone give me the accurate answer? I can use the calculator because I don't have to give JEE anymore. So this comes out to be 4.76 approximately. Got it? Understood, people? So this is very important over here. This basic idea is extremely important. JEE Advanced takes complicated questions and then puts a twist like this somewhere in the middle. So this is important. Perfect. Awesome. Now let's move on. So this is just, you know what we did over here, multiply both sides with 100, divide both sides with 105. This is the mathematical form of the same. So you don't need to worry about it. While you will be solving questions, you don't need to remember this. As I always say, physical chemistry does not need formulae, so no need to remember this. Just remember the statement. Statement will be helpful for us. Chalo. So, ये करते हैं अब. A mixture of A and B has 30% A by mass. 30% A by mass बोले तो percentage weight by weight of A is equal to 30 grams. How do I read this, people? What's the better way to read it? The better way to read it is, I have 30 grams of A in 100 grams of solution. Yeah. Now you're chemists. Now you know these fancy cryptic words, these fancy cryptic statements. Now you know how to decipher them in English. ये complication को आप simplify कर सकते हो. You're a chemist now. Perfect. We have to define the mole fraction. Yeah. And we know that the mixture is only A and B. Yeah. So can I write that I have 30 grams of A and 70 grams of B? Obvious, right? If you have 100 gram solution, 30 gram is A, so 70 gram is B. I don't think there's any rocket science over there. Perfect. Now all we need to do is calculate the mole fraction of A in the mixture. Perfect. कर लेते हैं. So mole fraction of A is equal to moles of A divided by total number of moles. Let's do that. Moles of A, given weight, divided by molar weight of A, that is 60. This is moles of A, half. Divided by total moles, that is moles of A plus moles of B. Moles of A is again 30 by 60 plus this board is so weird. So यहाँ पे what is the number of moles of B? 70 divided by 210. This is all we have to calculate. Not that difficult, I'm sure. कर ही लोगे ये तो आप लोग. So this is what, 1 by 2 is also 1 by 2 is 1 by 3. How much does it come out to be? 1 by 2 divided by 5 by 6. Right? I hope you know how to add 1 by 2 and 1 by 3 together. This is equal to 1 by 2 into 6 by 5. 3 by 5. Perfect, हो गया. Mole fraction, beautiful fraction. You can resolve it into a decimal if you want. No need to go there. So, mole fraction of A is equal to 3 by 5. Therefore, mole fraction of B is equal to 2 by 5. Because both of them have to add up to 1. So, 3/5 is A, 2/5 is B. I used to saying it's a silly question. Absolutely, it's silly. But imagine if someone is studying this concept for the very first time. This question allows them to digest the concept very well. Right? See, my duty over here, I'm telling this to everyone out there, and especially to all of you who are new over here, that my duty is to take everyone in the class from basic to advanced level. Okay? So, everyone will benefit over here. Ritik, now the syllabus hasn't changed in the last 50 years. Why will the questions change? Change करना तो मैं XY लिख देगा यहाँ पे. Fine. Hey, that's the thing about online teaching. You guys know all the secrets. Earlier, every year you think every year there's a batch of new students, but the teacher is doing literally the same thing. Chalo, now the next way to define things is mass by volume percent. Percentage weight by volume. Now things are getting trickier. Okay? It represents the mass of solute in grams present in 100 milliliters of the solution. This is very important now. Grams of the solute in 100 milliliters of the solution. The previous one was grams in 100 grams. Over here it is grams in 100 milliliters. Yes. Gangsta is asking, sir, NEET 2024 का सिलेबस बदलेगा? नहीं बदलेगा भाई, इतने सालों में बदला नहीं है. अगर बदलेगा तो सारी दुनिया पलट जाएगी. अगर उनका मन होगा पलटने का तो वो पलटेंगे, but I don't think that's going to happen. So it represents the mass of solute in grams present in 100 milliliters of solution. Same jazz. Again, no need to remember this formula. When we'll solve questions, we'll understand this better. But what you have to note down is this: volume conversions. This will be very helpful for your JEE. This is helpful for JEE because a lot of times they play with units. They will give you the volume in decimeter cube and they will give you the volume in decimeter cube. They will ask the answer in centimeter cube, etc., etc. So just read this and write it down if you can. Okay, cool people. The Avambal Manicum, I will suggest you things later. Let's just do this. Eknoor, I'm glad. I'm helpful. Yeah. Ritik is saying screenshot time. Le lo bhai screenshot. I'll move to the side. Let me give a nice pose for the screenshot. Yeah. Okay. Time to move on, my friends. Now we have volume by volume percent. So initially it was weight by weight, then weight by volume, now this volume by volume. It represents the volume of solute present in 100 ml of solution. So basically this is X milliliter in 100 milliliter of solution. Okay? And I'm sure right now some of you are like, sir, wait, what's going on? Why do we need so many different ideas? As I said, I will tell you, don't worry. So again, no need to remember this definition. Let's understand this jazz from here. You were giving me the example of cough syrup, right? Cough syrup contains 5% volume by volume alcohol. This V by V is very important over here. What does this mean? This means that I have 5 milliliters of alcohol, which is generally C2H5OH. Yes, I've got 5 milliliters of alcohol in 100 milliliters of cough syrup. Yeah. If you have a bottle of cough syrup lying around at your home, or if you are so inquisitive that you want to buy a cough syrup bottle just to read this, please do so. Okay. At the back of a cough syrup bottle, there will be different concentrations given for all the constituents. Different concentrations will be given for all the constituents. Okay. Fine. Prashant is watching from Nepal. Very nice, man. High five. Ayush is saying, sir, when will we know that our life is now... Ayush will talk about that later. Kunal is saying sanitizer mein. Yes, even in sanitizer, you have the same type of concentrations written. Dekhna. And you know what? This is how some companies try to fool us. Okay. So in sanitizer, as far as I remember, they need at least 70% volume by volume of alcohol in the sanitizer for it to be effective. But they write 70% and give some different unit of representation. So you think it's 70%, but when you convert that to volume by volume, it turns out to be something like 30%. Sometimes they do that, okay? And then there are some very smart people who take sanitizer and they mix it with water. they mix it with some perfume, they mix it with glycerin, they're like, I've made super sanitizer because it smells good now and I've made more of it. उनको कौन बताएगा कि अमृत नहीं है, वो सैनिटाइजर है. Education, I was saying I'm from Switzerland. Okay, high five to you as well. Yeah? Cool. I've literally seen videos of people, these popular influencers on YouTube. Back in the time of COVID, you know, they took a bottle of sanitizer and then they put it in some glycerin, put some perfume in it, put some water. They're reducing the concentration of alcohol. It's not a sanitizer anymore. Whatever. The world is full of morons and we can't do anything about it. So, I'll come back here. Vasant is from Antarctica, very nice. Actually, I'm from Russia. My name is Vladimir. Today we study concentration of solution. Let's come back to class. Imagine what will happen to the people watching this as a video after the class. ठीक है. Manish is asking, when will you start structure of atom? After this chapter is over, which will be one more week of this. Okay. Chala ji. So my dear friends, mole fraction is generally for any type of solution. Yeah. Any solution. Let's say you have an alloy. Okay. Let's say I have an alloy. Let's say I have steel. Now steel has multiple components. You have iron, you have carbon, you have this and that. Now the thing is that if it's a solid solution, I can very easily calculate the number of moles of things that I've put in just by looking at their weights that I've used to make the alloy, and I can calculate the mole fraction. Yeah. But now imagine that for a solid, if I have to calculate the volume, does that make any sense? Will I ever use percentage weight by volume for a solid solution? No. Yeah. Volume makes sense when I talk about liquids. Yeah. Getting the idea? Because I can measure liquids easily in volume. I can very easily measure, okay, this is 100 ml, okay, this is 1 liter, yeah. This bottle, if a liquid fills the entire bottle, it is 1 liter. So my dear friends, now you understand why there are different ways to write about a solution. Mole fraction is generic, you can use it for anything. Perfect. But now, let's say I am, I'm someone who is selling a solution, okay. I sell some solution. So I mix 2 grams of this with 5 grams of this. So if I'm measuring my solution in grams, it's easier to convert it into percent weight by weight. Awesome. Mass by volume percent. If I am dissolving salt in water, let's say, I can tell you, I have dissolved 5 grams of salt in 100 milliliters of water, something like that. Yeah. So this particular style is used when we are dissolving some solid thing into a liquid. Yeah. So we started with dissolving a solid, now the entire solution is liquid. So percentage weight by volume makes sense. If we are mixing 2 liquids together, let's say, yeah, if we are mixing 2 liquids together, I took 10 ml of this, 50 ml of this, volume by volume is easier. Getting the idea? So depending on how I create the solution, whatever is easier to me, I use that. As simple as that. Fine. So now we know the first 4. Let's come to the 5th one. Grams per liter. See, grams per liter, if you notice carefully, it's very similar to percentage weight by volume, yes? Very similar to percentage weight by volume. So let's read what this is. It represents the mass of solute in grams, grams of solute present in 1 liter of solution. Let's say I gave you a solution and the solution is, let me take an example over here. We'll look at this example later. Let's say I make a solution. I make a solution and I dissolve 20 grams of salt in 100 milliliter of solution. Let's say this is a solution that I give you. I'm like, okay, bro, come here. I have to give you a very important solution. This solution has 20 grams salt inside 100 milliliters. Cool. What is this? This is basically percentage weight by volume is equal to 20. Okay, awesome. But then what you want to do is you want to sell the solution again. And you want to earn some money. And you want to show that it's your solution, not my solution. So you say, I will change the nomenclature. I will multiply both sides with 10. This is what? This, I can write it as 200 grams of salt in 1000 ml of solution. 1000 ml क्या होता है? 1 liter. हो गया. Same solution. You're just multiplying 10 on both sides. Why? Because you want to sound smarter. That I've designed this solution and I have put 200 grams in 1 liter, 200 G per liter. Same things. Fine. So this one over here, a solution is 0.5 grams of NaCl in water. What does this mean? This basically means there is 0.5 grams of NaCl in 1 liter of, again, solution, not 1 liter of water. Okay? Total solution contains of water and NaCl. Right now we don't know what volume NaCl is occupying because we don't know the density of NaCl, yeah? We just know the weight of NaCl. If I give you the density, okay? If I give you the density, let's say, okay, random assumption, that density of NaCl is equal to कितना किया जाए 1 gram per milliliter, let's say. Let's say density of NaCl is 1 gram per milliliter. So how many milliliters is this? This is equal to half a milliliter. 1 gram per milliliter. So in this solution, yeah, in 1 liter of solution, half a milliliter is NaCl and 999.5 milliliters is water. Cool. Chalo. Grams per liter is also done. Now let's come to parts per million. Okay. Now, when do we use parts per million? Parts per million is used when the concentration of something is very, very minuscule, very small. For example, the amount of carbon dioxide in the atmosphere can be written in parts per million, which is an example that we've taken over here. Parts per million is for things that you don't need a lot of amount. Very, very small things. Now, over here, do you notice that it says parts per million? It doesn't say weight per million. It doesn't say volume per million. It just says parts per million. And to understand what this parts means, I will remind you of recipes that you use in the kitchen. Recipes aapko pata hai? Yeah, everyone knows what recipes are. So in recipes, sometimes they say use 1 cup of rice, 1 cup of water, and 1 cup of dal to make something, let's say. Yeah. What is that 1 cup? That 1 cup is a measurement of volume, right? 1 cup of rice, 1 cup of water, 1 cup of dal. Let's say you have to mix that for a recipe. So instead of saying 1 volume of this, 1 volume of this, 1 volume of this, I'll say 1 part. Okay? Fine. This word part can be used for volume. This word part can be used for mass. Okay? 1 part, for example, over here it's written by mass. So over here, how do we interpret this statement when it says by mass? I interpret this statement as 15 grams of CO2, 15 parts. They've mentioned that it's by mass. So you will read it as 15 grams of CO2 in 10 to the power 6 grams of air. Air is what? Basically your entire solution. Got it? So there's 15 grams of CO2 and 10 to the power 6 grams of air. So when it says by mass, you read it in terms of grams. Okay. Now let's say instead of by mass, they said by volume. Instead of by mass, they said by volume. So how would we interpret that statement? Replace the gram with milliliter. Done. Understood? So parts per million represents the parts of solute. Depends. It could be written by mass, by volume, by moles. In 10 to the power 6 parts of solution. Okay. Is there a voice distortion? Let me check. Hello? What up? What up? What up? What up? Is it better now? That I've removed the mic, is it better right now? हाँ, ये mic हो गए पुराने and their wires have become very rigid, so they just keep interacting with the shirt. पुराने हो गए, mic नहीं लेने वाले. चलो, if it happens again, let me know. All right. Fine. Parts per million is clear, I'm sure. Okay. Perfect. So, my dear friends, take this statement and convert it into percentage weight by weight for CO2. Percentage weight by weight for CO2 is equal to, please tell me the answer. Convert this into percentage weight by weight. Very simple. This is a statement, you have to convert it into, what do you have to convert it into? You have to basically convert it into grams of CO2, yeah, X grams of CO2 in 100 grams of air. That's what you have to come to. From here, you have to come here. How much? Very simple. Yeah. So this is 15 gram in 10 to the power 6 grams. You just have to convert this into 100, right? So let's divide by 10 to the power 4 on both sides. So 15 divided by 10 to the power 4 gram in 100 gram. हो गया ना? 10 to the power 6 by 10 to the power 4 is equal to 10 to the power 2, that is 100. Alright, so my dear friends, 15 into 10 to the power minus 4, or better still I'll write 1.5 into 10 to the power minus 3 percentage by weight. Understood? This statement can be converted into this statement, and once you convert this statement into this statement, this is basically the statement for percentage weight by weight. Mayur and Dhanupriyan, what part did you not understand? I will explain again, don't worry. Is it so? Someone new? Some disturbance is still there. How do I create a gap between this and my shirt is what I'm thinking. If I place it lower on my shirt, then it's not going to sound as great. कोई ना, कर लेंगे manage. Maybe this works. So I'll give you the idea once again. See, what does this statement mean? This statement basically, if you have to simplify it into English, we are doing that as chemists. This statement means I have 15 grams of CO2 in 10 to the power 6 grams of air. Right? इसको बहुत ही अच्छे से लिखना है आपने, तो you can write yeah. Can I write that? This is what it means, right? 10 to the power 6. I have to convert this statement into X grams of CO2 in 100 grams of air. Why? Because this is a statement that tells me about percentage weight by weight. How do I convert this? Basically, divide the statement over here on both sides with 10 to the power 4. 4 zeros cancel 4 zeros. You have 100 grams of air. This, my dear friends, is your percentage weight by weight. Okay, fine, cool, awesome. Yes, Ankush, I was in Lakshya Patiala back in 2010. ठीक है, ये हो गया. Parts per million is clear. अच्छा, similarly you have parts per billion. Okay, this is parts per million. Same thing is parts per billion. You write it as ppb. So x, or let's take a random example, 5 parts per billion. How do you read this? Basically this means 5 grams of solute in 10 to the power 9 grams of solution. So billion में 10 to the power 9 आ जाएगा. Million was 10 to the power 6. This is 10 to the power 9. Rest of the things remain same. Cool. Now let's come to the meat and potatoes of this class. Molarity. It is very important. Got it, someone new. Very nice. हाँ जी, ठीक है. Molarity. Molarity represents the moles of solute present in 1 liter of solution. Moles of solute present in 1 liter of solution. Okay. Molarity is always represented with a capital M. Bada M. Can you see capital M? So how do I read this? This basically means 1.7 molar NaCl. That's how I will pronounce it. I have an aqueous solution that is 1.7 molar NaCl. How do I read it? Very simple. Obviously, it's very simple. 1.7 moles of sodium chloride in 1 liter of the entire solution. Okay? 1.7 moles of NaCl in 1 liter of the entire solution. It's as simple as that. Is no rocket science. ठीक है, इतना मोल है तो है ना, मैं क्या करूं इसका. You want to do an example just for fun? Very basic example. Let's say I have 88 grams of CO2 dissolved in 1 liter of solution. What is the molarity? Quickly, people, can you tell me? What's the molarity of this solution? 88 grams of CO2 dissolved in 1 liter of solution. What's the molarity over here? For those of you who are watching this as a recorded class, you can skip through these random parts. Obviously. हाँ जी भैया बताओ. Dhanupriyan, very nice. Either Dhanupriyan's internet is very fast or Dhanupriyan is very fast. Whatever the case may be, very nice. So, molarity कितना आ जाएगा? Moles per liter. So, how do we convert grams into moles? Moles of CO2 equal to given weight divided by, what's the molar weight of CO2? 44. 12 plus 16 plus 16. This is equal to 2. So you have 2 moles of CO2 in 1 liter. So molarity is equal to 2. Badhiya. Everyone else's internet is also working, albeit tad slower. That's fine. So someone new, Dhanupriyan, Harsh, and Eknoor have also given the answer. Very good job, people. Now comes the odd one out. Just read the statement that's given over here. In the statement, can you see a difference? This statement looks very different from all the other concentrations. How? Molality. I have no idea who was dumb enough to use such similar words for such different ways of concentration. Molarity, molality. What the hell? Molar, molal. Why couldn't they have called it something else? They could have called it something else, right? They could have called it bazooka. Sounds nice. But they call it molality. As if you have a lisp and you can't say molarity. So it represents the moles of solute present in 1 kilogram. पहले तो आगे kilogram. Okay, interesting. Kilogram of solvent. Everything is like molality would have been. Yeah. So first of all, we have kilograms over here. Very nice. Till now we've been dealing with grams, liters, milliliter, etc. Chalo, fine. Still, this is a unit of weight. We have done percent weight by weight, whatever. But the most interesting thing over here is solvent. Till now, all the concentrations that we've studied were all regarding a solution. But do you realize this makes life much more simple? It's easier for you to tell everyone what is your solution, right? You don't have to calculate the volume of the solution. If you dissolve 2 moles of salt in 1 kilogram of water, 2 molal. As simple as that. अरे भैया ये mic हम फेंक देंगे कहीं तो. What can I do in order to mitigate this? Just a second, people. Okay, I have an idea in my mind. That idea is very dumb, but I'll try it. Just give me 1 second, please. Sorry for the weird disturbance that you might have heard. Now I'll use this as a handheld mic. Okay. देसी जुगाड़ कर दिया हमने. ऐसे लगा देते हैं. So I have a handheld microphone now. Better? I hope it is better. Example is 2.5 molal. Okay, you don't say molar, you say molal. 2.5 molal aqueous solution of glucose. Fine. And if it got worse, then the mic is totally gone. We'll fix it in the next class. Chalo. So what does this mean? This simply means, okay, this is very simple. This means 2.5 moles of glucose, okay, in 1 kilogram of water. Over here, we are not talking about solution, we are talking about solvent. It's very easy to first of all tell you that, okay, I've dissolved 2.5 moles of glucose in 1 kilogram of water, so done. Yeah? Easy to tell. You don't have to calculate the total volume of the solution and divide by, simple, 1 kilogram of water. Perfect. भैया 1 किलोग्राम पानी में 2.5 मोल चीनी घोल के दे दो, मजा आ जाएगा एकदम. Okay. Do you realize what's the biggest advantage of molality? And if I compare molarity to molality, so we are science students, so we take these terms seriously. Imagine a commerce student listening to us right now. Molarity. Alright, anyway, whatever. What's the difference? This is moles per liter of solution. This is moles per kilogram of solvent. my dear friends, the thing is that liter is a unit of volume. And we all know that with temperature, the volume changes. Yes, volume changes with temperature. Two people have already given the answer, I think. Yeah, Citrus has answer, given the idea. यार mic जैसे तैसे काम चला लेते हैं. The class is almost about to end. I'll throw this mic away after the class is done. So yeah, volume depends on temperature. So this molarity changes with temperature, okay? Changes with temperature. So let's say you work in a cold place. Let's say you're working in Russia once again. I give this example all the time. Huh? Someone using give the Russia example. Yes, I was about to give the Russia example. Let's say you're a chemist working in Russia. The temperature over there is 0 degrees Celsius. You make a solution. You send it to India. The temperature in India is 30 degrees Celsius. Then you'll be like, the Russian guy gave me a wrong solution. Not going to do the Russian accent again because we've already done that in the class. This guy does not change with temperature, yeah? So no matter when you make the solution, no matter where you send the solution, weight will remain weight. Weight is constant. So that's why there's an advantage of using molality over molarity. Fine, cool. So, concentration of solution, done. Let's do one question, and then the rest of the questions regarding the concentration of solutions, we'll do that in the upcoming class. 117 grams of NaCl is dissolved in hydrogen contributing 1500 cubic centimeters of solution. What is the molar concentration? Molar concentration, so you have to calculate the molarity. Basically, whatever is given over here, ultimately comes to a statement that with X moles of NaCl in 1 liter of water. This X is your answer. Right now, what is the statement? The statement is 117 grams of. Don't do that. 1 liter of solution. So what's the statement over here? 117 grams of NaCl is there in 1500 centimeter cube of solution. Cubic centimeters is basically equal to milliliters. Okay, cubic centimeters and milliliters are the same. So this is basically equal to 1.5 liter. This is basically equal to 1.5 liter. So you have to convert this into moles and you have to convert the entire solution to 1 liter. If I have to convert it to 1 liter, how do I do it? Divide both sides by 1.5. Yeah. So I can say divide this by 1.5, divide this by 1.5. ये कट जाएगा, बन जाएगा 1. So I have 117 grams divided by 1.5 grams of NaCl. Yeah, in 1 liter of water. Fine. Now, my dear friends, I have to convert this into number of moles. Moles of NaCl will be equal to given weight divided by molar weight of NaCl. What is the molar weight of NaCl, people? Vishwajit, I will change the microphone tomorrow. I don't have any other microphone in the class. So let's just finish this particular question and I'll definitely break the microphone apart. I'm really sorry, people. I didn't expect the mic to be not working. तो NaCl का weight कितना होता है? 23 plus 35.5. 23 is NaCl and chlorine is 35.5. Total is 58.5. So divide this by 58.5. Now the interesting thing is that, so moles of NaCl are equal to 2 by 1.5. 1.5 is basically 3 by 2 is equal to 4 by 3. Molarity is 4 by 3. Done. Very simple question. If you want to see the solution, just rewind and watch it again. Now, one more question that is there. I will give that to you as a homework. Okay. Do this as your homework, people. And in the next class, which is going to be there most likely on Monday, but I will let you know the schedule. There are some more things that we are planning. So if the schedule changes, I'll let you know. Okay. So what volume of 1.71 mole NaCl solution will contain 0.2 mole of NaCl? This is your homework question. You can answer it in the comment section down below. Fine. Dhanupriya is saying, can you live stream grade 12 classes too? I will do that today. Okay, the solid state class, I'm going to do a live stream for that. Fine. So people, for this class, that is all that we'll do. I hope you enjoyed it. Make sure to hit that thumbs up button. If you enjoy my very weird style of teaching, then make sure you share it with at least one friend of yours, because we want to make this bigger eventually. It'll be helpful for you. It'll be more helpful for me because, yeah, obviously. How I summon you, I'll ask the team for a different microphone. Yeah. Chalo. So people, that's it from my side. Thank you so much for watching this particular class. Please solve the homework and we'll see each other once again very, very soon in another class or in another session or whatever. Chalo ji. Bye bye. Thank you so much.